Question 18 reads, at time t equals 0, a ball was thrown upward from an initial height of 6 feet. Until the ball hit the ground, its height in feet after t seconds was given by the function h above, in which c and d are positive constants. If the ball reached its maximum height of 106 feet at time t equals 2.5, what was the height in feet of the ball at time t equals 1? This is a tricky but doable y equals f of x problem. Let's start by dissecting what information is given to us in the problem. So the first thing we see is that at t equals 0, a ball was thrown from an initial height of 6 feet. So we're already given one of the xy, or here t, h of t, solutions to the problem. We know that if we plug in 0 for t, we should get 6 out for the height. Okay, moving on. Until the ball hit the ground, its height was given by the function above. Okay. If the ball reached its maximum height of 106 feet at the time t equals 2.5, that's our second clue. So if we plug in 2.5 for t, we should get 106 feet. And very importantly, that's the maximum value of the function. And what we're being asked at the end of the day is, what is the height in feet of the ball at time t equals 1? So at the end of the day, we're going to want to be able to sub in 1 for t and come out with a numerical answer. In order to do that, we're going to have to solve for c and d. Now, let's start with the easier point that's given to us, 0, 6, and just see what happens when we plug it in. So if I know that 6 is going to be the answer I'll get when I plug in 0 for t, 4 times 0 is just 0, right? Oh, yep. d minus 0. There we go. That makes better sense. Then I'll get that 6 is equal to c minus d squared. That doesn't explicitly solve for c or d yet, but we're on the right path. We've got some information. Looks pretty simple. Now let's handle this next point that's given to us, 2.5, 106. So what that means is that I'll get 106 out if I plug in 2.5 for t. 4 times 2.5 is 10. And there we get 106 is equal to c minus d minus 10 squared. Now you could go through a lot of trouble of squaring out d minus 10 and trying to set these two equations equal to each other somehow by finding a common factor. It's going to be a lot of mess to solve for c and d. The fast way to do this problem is to recognize that this is the maximum value achieved. Now, what would make this function have the highest value it could possibly have? Well, we're taking a number c and we're subtracting out a number. And because you know that c and d are positive constants, c is a positive number, d is a positive number, and it's being squared. So we have a positive number minus a positive number. That means that the maximum value this thing will ever achieve is if we keep c and take out as little from c as possible. The smallest amount we could possibly take out from c is if this whole thing here were equal to 0. If that whole thing there equaled 0, we would get the maximum possible value for the function. So, what's going to make that whole thing equal 0? Well, only if d is equal to 10. If d is equal to 10, then that means when we plug in 2.5 for time, as we already have, we'll get the maximum value of the function. So now we know that d is equal to 10. All right. If d is equal to 10, we can just sub that back in to this equation that we've already figured out with the first point and solve for c. So let's do that. 6 is equal to c minus 10 squared. 6 is equal to c minus 100. So what does that mean? C is equal to 106. And that works out just fine, because notice at this maximum value equation, if we plug in 0 for this whole chunk here, we should get 106 equals c. So this checks out both ways. We've now solved for c and d, and we're ready to answer the question. We want to know what was the height h of t if we plug in 1 for t. So h of 1 is equal to 106, that's the value we found for c, minus 10, that's the value we found for d, minus 4 times 1, which is 4, squared. So h of 1 is 106 minus 6 squared, or 106 minus 36. And that's why the correct answer is 106 minus 36, or 70.